Alright, we're going to do another example on secant lines. This time it's going to be a trig function. So let's go ahead and read this question together. What is the equation of the secant line of sine of 2x on the interval negative pi over 2 comma pi over 4? So once again, remember that these are two x values. This is your first x value. This is your second x value. We're trying to find the equation of the secant line. And remember, the slope of the secant line, always remember, is the average rate of change. And so I'm going to just write AROC on here to remind you of that. So let's go ahead and find the equation of this line. We're going to use the same steps as before. Let's go ahead and take a look visually what this one looked like. I could actually make that a little bit bigger. Okay, so what is the equation of this line right here, going from negative pi over 2 to pi over 4? We just need to figure out this equation. And the secant line does extend. It's not just a segment. I mean, it is a segment, but at the same time, that segment has an equation if that line were to extend onward. So just keep that in mind. So let's figure out how to find that equation. Okay, first thing you're going to do is label each x value they gave you, x1, x2. Pretty simple, right? Just like the last problem. Step 1 is just to label your interval that they give you, x1, x2. Notice this is a closed interval. It needs to be closed interval in order to find the secant line equation. Alright, then you're going to find y1 and y2 just by plugging those x values in. So if you plug in negative pi over 2, the 2's cancel, you get sine of negative pi. Looking on the unit circle at negative pi, we know it's the same as positive pi, which is 180. The y value would be 0. So y1 is 0 because we plugged in our x1 value to get that. Plug in x2, we get plugging in pi over 4. 2 over 4 becomes pi over 2. We know that sine of pi over 2 is 1. Therefore, y2 is 1. Remember, pi over 2 is 90, so that's why it's 1, in case you think of unit circle in terms of degrees. So now we're going to determine the slope of our secant line by writing y2 minus y1 over x2 minus x1. Plug all that stuff in we just figured out. So it's going to be 1 minus 0 over pi over 4 minus negative pi over 2. That's going to become a plus. So it'll be 1 over pi over 4 plus pi over 2. And pi over 4 plus pi over 2, by finding a common denominator, we will get 3 pi over 4. We will flip this fraction since it's 1 over 3 pi over 4. Essentially what we're doing is, since whenever you do 1 divided by something, you just flip that fraction so it becomes 4 over 3 pi. So there's the slope of our secant line. Now, that's kind of abstract. We're going to come up with a decimal in a second, but in order to write a accurate equation, I'm going to leave it that way. Alright, so here's our line formula. Y equals mx plus b, as we learned before. We're going to plug our y1 in for y. We're going to plug in our x1 in for x. Now you could use x2, y2, just be consistent. And then we're going to plug in m, and we're going to solve for b. It's going to get kind of complicated here, but we're just multiplying two fractions here on the right. 0 is pretty simple, right? And so the pi's are going to cancel right here, okay? The 4 and the 2 is going to become a 2 on top, and we're going to keep the negative. So we get negative 2/3 on the right, but we have 0 equals negative 2/3 plus b. So when we add 2/3 to both sides, we'll get b equals 2/3. Alright, so we found b, we found the slope. Now we just plug that into the equation real quick. So instead of writing y equals mx plus b, we replace m with what it is and b with what it is and leave the y and the x the same. In case you were wondering what these decimals come out to, this one is approximately 0.4. Alright, which as a fraction, I'm not sure why I didn't write this. As a fraction, that would be around 2/5, okay, just approximating. And then 0.6 we can leave because for a y-intercept it's okay to have a decimal because it's just on an axis. So this is kind of our final answer here. Let's revisit this equation and see if it makes sense. It does look like it goes up about 2 for every 5 units over, which makes sense. Again, the actual slope was 4 over 3 pi. And the y-intercept, if this were to keep going down, would intercept at about, and I've already forgotten, 0.6. Now, that looks negative to me, though. I'm going to have to check my work here. Okay, I see now why, because this is actually the y-axis. This is just labeled over here. So at x equals 0, it does indeed intercept about 0.6. Had to look at that for a while, but I graphed it this way just so it would be easier to read. Alright, so if you have any other questions about secant lines, let me know, and in particular equations of secant lines, including the slope and the y-intercept.